So you've seen the UI, still the same thing, same server, same data store. We just layered those capabilities on top. The algorithm itself runs on the analytics engine that Ranjan mentioned before. So the analytics engine or engines are just x86 platforms. So not typically, we are an Ubuntu shop. So we run Ubuntu, we run a DPI engine on top of that, we run a flow collector, and then we have different processing layers on top of that. You can have one appliance, you can have up to 12 of those appliances. Each appliance typically does 1 million to 2 million flows per minute. So we can end up with like 10 plus million flows per minute in one system, in one deployment. Flows per minute doesn't tell you anything about the scale. If you look at an endpoint, typically an endpoint creates, in average, 30 flows per minute. So if you have 10 million flows per minute as capacity, you can basically monitor a lot of endpoints in like one server deployment. And if you need to go beyond that, you just use a cloud platform sitting on top. So there's a lot of scale. What hasn't been, I don't know whether it really came through from the underlying application telemetry detection perspective. What makes it really unique is we can inspect traffic at scale using those techniques. So the mirroring and the flow collection helps us to only hit those appliances with a fraction of the bandwidth that we are actually inspecting. So we can inspect a terabit of traffic, providing DPI capabilities with just a few hundred megabits per second hitting the analytics engine, which is x86. So that multiplier is significant and gives us the ability to go to provide that not only at the access layer, but also at the core and within the data center, which is very, very unique. So you want to keep that in mind. So we are not really bandwidth constraints based on how we process the data. So what you see here, again, is in flight, in development. It's our security analytics dashboard. It gives you an idea of current threat indicators that we have seen, the responses that we have executed, high-risk endpoints, and also where are those endpoints. So we're going to focus on, I can drive that, we also have the ability to basically show the result of our machine learning algorithm here. So that's basically the model inside of each and every of those analytics engines. And what you see here is what we talked about before. So you see clusters of devices that are behaving similarly. So that's a 3D representation of a 500-dimensional vector space. So we're using, what do we use? Tensor projector to do that. So we don't use TensorFlow, but that's an open source tool that you can just use to visualize your multidimensional space. So those devices here, so we have loaded that from actually an actual customer deployment. So those devices are console servers that are part of an IoT accelerator, of an IoT network that basically does monitor a particle accelerator. So there are not too many of those in the world. But why do we use that? Because I have a lot of IoT devices on that network just to try it out. But we overlay that with real data in our lab. So we have those cameras here. So those are APs and cameras at the same time. The AP part is not that interesting for the demo. It's really the camera part, because the camera is an IoT device where we basically create an anomaly and the anomaly is just a basic network scan to change the behavior of the device and show you what's going to happen, which Steve is going to simulate. So ultimately, what's going to happen as he initiates the attack. So it's a live demo, so let's see whether it's going to work. See. Yeah. So he has initiated that, and if you see that thing blinking here, if you see that thing blinking here, you will see what IP address and MAC address that is that he created that anomaly for. So We are not done yet on how the workflow looks like backwards to the main dashboard. But ultimately, within the dashboard, you will see, once it kicked in, you will see a new behavior anomaly showing up here. And from there, see, here we are. Did you see that? Everybody paid attention. It went from 0 to 1. You can click. You can click on that and basically get a filtered view of all of the threat indicators that we have. So we have different classes of threat indicators, as mentioned before: URL, DNS, IP, brute force, and behavior anomaly. For behavior anomaly, you see the source, so that's the IP address. And from here, you can basically figure out what's going on. So the response status is running. So obviously, we are doing a lot of things at the same time. If you exactly want to know what we are doing, you just click on that. So you see the response that is running and is almost complete. So I think the status will update in a second. So what we have done is that IP address was basically the simulated anomaly that is matched against the rule engine that you can configure, so which basically describes what you want to do when you see an anomaly. In this case, it hits a workflow that we call quarantine infected user, which does more than just quarantine. See, it's updated now, which basically runs a set of actions at the same time. So we kicked off a workflow integrating with Workflow Composer to create a Jira ticket. We added the Jira ticket description. We also created an email that went to Steve's account that we are going to look at in a second. We also blacklisted the device using access control. And we also sent an email that the workflow was completed successfully.
Was there information on what the anomaly actually was that would be fed up to an operator?
What the anomaly, so that's the fuzzy clustering part. So right now, we don't have that information. We just know we have an anomaly and we just kick it off. So we need to figure out right now what caused it. Once the fuzzy clustering is part of a product, then as a new cluster based on new flows is created, we can point to the exact flow that caused the anomaly. And then you can also say, hey, I want to whitelist that or not, based on, hey, that's our monthly software update that you should ignore.
Can the administrator relax the rules or change the configuration?
Yeah. So first, just to complete the workflow part, so we are leveraging the underlying workflow engine that is part of the XMC server, which again is something that is customizable, so you can stitch together different steps and also figure out whether each step was successful, what the output was, and things like that. So that's all part of the system here. The configuration of the rules itself, you just, what did we use? That's one, yeah, that's true. You can basically decide based on threat subtype, attacker, IP, severity, what policy, what location that user and device is in, what you're going to do. And in this case, we said, hey, we don't care about any of those. We just care about the fact that it's a behavior anomaly. And then the workflow that we kick off is QT, very telling. And QT, you have those custom inputs, so you can decide whether you want to blacklist or not, whether you want to create Jira or not, whether you want to create a ServiceNow ticket or not. So you can knock yourself out, so to speak, in terms of customization, but we also deliver a set of default rules and capabilities as part of that.
So you've been talking IoT and all that. So can you also use this as basically like a UEBA, right? So tie it back to DNS.
We have a lot of interesting discussions about that. That would be the next logical step. So I'm always a friend of crawl, walk, run. So we start in one area, do that well, and then do the next thing. So it would be the next logical step. Yes, absolutely.
Scissors. Because the flows are coming in from your devices at this point.
We don't care whether it's IoT or not. It's just the anomaly detection part.
What about like a Splunk or SIMS or that, feeding all of that in? I mean, are you guys, do you handle all of that today? Can you?
We can have external triggers. So once the product is released, we can basically normalize incoming Splunk, Palo Alto, Checkpoint, Fortinet events and respond as part of that. So it's always the question, so who's the master? Who does the Uber correlation? Is it us or somebody else? Or So, But definitely the automation part and the tie-in with infrastructure is obviously unique, and then you're building up from there.
At the start of and I think you touched on this earlier, but at the start of the presentation, there was talk about all this is in a single data store.
Yep.
So what kind of compute and storage am I going to need? How does it scale? This is going to seems like it's going to
always a function of time. Yeah. So we have a layered approach. So the big resource hog in terms of storage is the raw flow data. The raw flow data we keep either in a distributed fashion on the analytics appliance. We use a flat file database. It's not really a database, but RocksDB, if somebody knows what that is, to keep the flows on the engine. And the engine itself then rolls up data on a regular basis. Either there's raw flow data that is pushed up, but typically we do 1 5-minute and 1 hour aggregations that roll up into a central database. Yeah. If you want to keep the raw data for long, then you push it into a cloud service. Yeah. That's what we do for the NFL, for example. Yeah. So you need to pay for that as always. Yeah. So other than that, as we aggregate data, the storage requirements are not that high. So typically our customers run between 1 and 2 terabytes of disk on the server side. Yeah? And that allows you to keep data around for half a year to a year. Yeah? But if you need to go beyond that or get more granular, then you invoke a cloud service or you push data into Elastic or whatever you want to. Yeah? So.
Yeah, just I guess, because that brings up a good point about like history, right?
Yeah.
So I have a device that this happens. Well, a month later, the same device. Well, I can try to go back and correlate it, right? And see why is this one device always happening?
Yeah, correct. I mean, the events, obviously, we keep for a year or longer, but the data underneath, obviously, you need to figure out what you're going to do. So what we also are going to do before we go GA is, as one of the actions that I didn't describe here is we can fetch the flow cache for that device at that time. So let's say a device had an issue a month ago. At that moment, we wouldn't not only create a PCAP for that device for the next 10 minutes, but we would also go into our flow storage on the engine and say, okay, fetch me all flows that you can find from that guy from day 30 and 5 days forward and backwards from that. So you create what we call a forensic package that you then can store somewhere else, but it's specific to that device. So if you go back after 4 months, you will still have those flows selectively stored for that device, but there must have been an event that allowed us to trigger that storage event. Yeah, but through that, again, you don't need to store everything for everybody. You only store then selective flows for that device that you have seen an event for a month ago, so to speak. But you store it at that point in time, yeah, and not going back. But you can also go back, yeah. But then it's cloud, then it's long-term storage, then it's going to be expensive or not. Yeah. Yeah.
So what you're showing here is essentially handling a physical entity. What if you had a VM workload?
It doesn't matter for us. Yeah.
But you're quarantining that port, correct?
Correct.
So that would affect all the other workloads on that server potentially.
I retract that. We don't change the port. So what we changed, so on wired and wireless, our switches behave a little different than other people's switches. So every MAC address creates a virtual port. So like you have a client MAC associating with an AP, which creates a virtual port or virtual interface, the same happens on our physical switches. So we don't change port policies, we change policies per endpoint. So we flip that. So if you have a server hanging off a top of rack switch and you have an ESX server with like 100 VMs on it, we blacklist per VM at the physical port. Yeah? If you want to reach out into VMware and change the distributed virtual switch config, then you can do it as well with a customized workflow. So that's not an issue, but you need to drive that by yourself. But you can change that. So we have vCenter integration for quite a while. You just pick a workflow and say, okay, use the existing vCenter API to blacklist. Yeah? And then you blacklist the virtual port, the port on a virtual switch, and then it's again VM.
Yeah.
VM and vNix centric. Yeah? So we are also the other parts of the demo. We didn't go into the configuration part, but talking about quarantine for a moment. So what we should see, as we had that device, so the device that caused the anomaly was 192.168.231.22. So what you see here is part of our network access control product. Again, security and automation, as mentioned before, really important. A nice side effect that our network access control solution provides is we create we don't have a good marketing term for that. I call it the end system state table. So as a side effect, we basically track in real time 50 attributes per end system, and those attributes get updated in real time as things change. And those attributes include MAC, IP, host name, device type family, switch, port, AP, SSID, timestamp, first seen, last seen, what policy is applied, why is that policy applied, when is that policy being applied. And you can also add custom data to it. So we have an API that you can write to and read from. So for example, per endpoint, you can add asset tags. So you want to find a device by asset tag number. Or if we have an MDM integration, we add IMSI and EMI and phone number. So you can look up devices by phone number. So you don't need to know anything about your device itself. MAC, IP, doesn't matter. So you go for other attributes. Yeah. So long story short, so that's the end system table that you're looking at right now. And what we also do per end system is we keep a history of events. So what happened here is that device itself, initially we applied the camera IoT profile to that device. Yeah. So it has certain access rules. And as part of the threat response, we changed it at 1:22:58, which is exactly when he did trigger the whole thing, to quarantine. And quarantine itself means different things to different people, and that's again customizable. So you can take a look at what that means for that specific device here. Just look at the policy itself. So the device got pushed into a blacklist policy, and the blacklist policy applies a quarantine policy specifically, and those are the services that are associated with that blacklist policy. Yeah. Yeah.
Do you have a sense of how much operational noise this creates? I'm thinking back to the days of IDS and then SIEM, where it was just alert, 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 and that's a lot of work for people to chase down and figure out what's real and what's not.
Yeah.
So.
Yeah. It's not only that, but once you do that, people stop looking. Yeah.
Exactly right.
Which is the biggest challenge. Yeah. So right now, based on what we've seen in early customer trials, our false positive rate is 0. I can't guarantee that after we have.
Again, 0.
We are recording, right?
So.
Wow, that's.
But we are still in development, so we haven't been exposed to everything under the sun yet. But it looks extremely promising. Yeah. On the anomaly detection side.
But false positive, if you're just talking about an anomaly, false positive, like, was that a security anomaly or just a regular production anomaly that's safe, right? What is a 0 doesn't...
Again, so that's lab testing. So once we release the product, we will provide a solid, hopefully a solid number along with that. Yeah, but yes. I mean, we have been in the IDS space for a long time. Actually, our DPI engine that is homegrown is developed based on an IDS engine that we developed quite a while ago. So we are pretty good with all of that stuff. And we definitely know that one of the biggest challenges is false positives. Yeah. But again, looks very promising. What we're also trying to do is we are trying to combine different techniques with each other. I didn't show that yet because it's not in the product yet, but if you look at a threat indicator, you can't just go with a one-dimensional perspective and say, okay, I see one anomaly, it must be bad. You need to take more things into account, and that's where you cross the line. Is that seem UEBA or not? So we're trying to walk that line to make a more solid call on, hey, there's really something wrong. Because if you're not able to reduce that to either no false positives or very low false positive rate, then there's no point even trying to deploy such a solution. Yeah, so we are fully aware of that. So yeah, so on the policy side here, so what you see is one of the secret sources also from Extreme, which is our policy management framework, which is a large-scale ACL and action management framework that allows us to deploy policies persistently and consistently across wired and wireless. So you've seen it before, we don't really make a difference between wired and wireless. So those policies get deployed to our access points in the same way as they get deployed to our access switches. If a device doesn't support that granular policy, we have an abstraction layer that allows us to translate that to ACLs, ACL names, ACL numbers from other devices. So you can mix and match those together. Yeah. So user-based ACLs, also an option.
Question for you.
Yeah.
So obviously we've seen it tied into Extreme Gear. You talked about
Yep.
possibly getting into the vSwitch through
Yep.
a workflow based off of whatever.
Yeah.
Will this work with other vendors' gear if you have a multi-vendor environment?
Yep.
So we can run this over the top and have all the data come in here, but then also execute actions on insert
absolutely.
other name brand switch.
Absolutely. Yeah. So in general, especially here in that space, we get user statistics from our customers. Roughly 25% of the devices that are integrated even today are non-Extreme devices, just to give you an idea. Yeah. So, and it's a specific focus for us to be multi-vendor capable. So it's part of our design in the product, and it's also part of our QA process. Yeah. So,
okay.
So we have, for example, I won't mention vendor names or customer names anyway. So we have large-scale examples where Campus 1 is Extreme, Campus 2 is a totally different vendor, and they run one unified security operations using that on top of it. So the admin doesn't really see whether it's Extreme or vendor B.
Right. This is one of the biggest challenges. Obviously, security is driving a lot of the new network innovation.
Yep.
But a lot of the systems seem to be very, very closed.
Yep.
Right. So, okay, if I want, vendor X's security suite, they control their devices. But if I want it to be multi-vendor, it's very, very challenging.
Correct. That's looking at go-to-market. That's an opportunity for us. Yeah.
Absolutely.
Exactly,
And in that case, so how do you bring in the data from other vendors to your?
So the data, so there are two things. He asked about enforcement. So enforcement is done through NAC, and within NAC we have the abstraction of capabilities. So is it a policy? Is it a VLAN ID? Is it an ACL name? Is it an ACL number? Is it an entire ACL? So if you look at user-based ACLs, everything is in a radius response, or the entire ACL statement. We can do that, and that's based on the device type. So that's the enforcement part. On the detection part, two solutions for that. One is what Ranjan mentioned. What we are doing for most of the NFL stadiums is where we deploy sensors that are picking up the data and feeding analytics. So while the sensor picks it up somewhere else, the enforcement can still be at the access layer because we have access control in place to do that. So that's one option. Or the enforcement can be done against a firewall in the core. That's the other option. Depends on when we don't find an IP in our end system table, then the next lookup is, hey, look at a firewall that we can use to block that device or blacklist the device.
But sensors are not possible everywhere, right? So
sensors are not possible everywhere. So you need to dive on this. We do support IPFix coming from the bigger networking vendors that are in our marketplace. Yeah. But IPFix is not always sufficient, I have to say that as well. Yeah.
Can't I put a tap and send all the data to?
Correct, you can do that, yes. Yeah. And we're also looking at driving down the cost of a tap, so you could go into a highly distributed scenario. Campus is never a problem. You have 10 gig pipes, you tap into that, that's it. But if you have a highly distributed scenario, it becomes really interesting on how you get the data. Yeah. So, yeah. But we are working on that as well. Okay, that's access control. So you've seen that. The pieces that we are tracking here, just a visual on most of the attributes. You can also try to find devices on a map, on a topology map. So again, tying together user, device, location, topology data in one database and index it the right way. That's basically our unique advantage. And that is true for wired and wireless. Configuration management for parts of a product might be different, but then you can single sign on from here into those devices. So let's say, I didn't try that out, so I don't know whether it's really going to work. But if you have a wireless controller, you can basically, see. It wasn't, I wasn't prepared, but typically you could single sign on from here into any of the devices if there's something that we don't support natively in that UI. Yeah? But most of the things for switching are supported. For wireless, at times you need to go one level deeper. Yeah? What we didn't show actually as part of the response, so we showed blacklisting, Jira email, see? So that's already 20 minutes ago we did do the simulation. So that's Steve's email account. So we don't look at his main inbox, but we have a folder that basically gives you the same data just in an email. Hey, we have seen this MAC address is blacklisted. You can look at the application flows there. The Jira ticket has been created, and here's the IP address and the MAC and the policy domain and everything you need to know. Yeah? If we would have created a PCAP file, you would also get a link to download the PCAP from the appliance as well. Yeah.
So you just showed wired, obviously, with the, finding it logically and all that. How are you doing that wireless?
Same
How do
thing.
I find it on a map? Like, where's that device?
Same thing.
I mean, where in the GUI do I go to find the map of this device is within this 1 meter area? Or
You're talking triangulation. So there are different levels of location. So our wireless controller does that for that. So obviously at the network access control layer, it's the MAC and the policy and the AP associated. When the AP changes, we see an event and we update our end system table. So what wireless also does for us is there's an integrated location engine that provides us area accuracy. So you can create zones or areas. If that endpoint moves in or out of the zone, that creates an event that also goes into network access control that can be used for geofencing. Yeah? If you want to go beyond that, then you can find it on a wireless heat map as well from here. So if you...
I'm just thinking like a wireless IoT device, right?
Yep. Yeah. Obviously, we didn't do the demo like this, so we should have probably done that going back. But if you go to an end system like this, we don't have wireless connected. But if you search that device on a map, those maps can be wired or wireless maps. So at the end of the day, it doesn't matter. So in this case, user error, sorry. Okay, we didn't create maps, even not for wired. Yeah? But it's the same thing. A map comes in 3 flavors for us. It's a topology map, which was wired, links, interfaces that you can overlay stuff. It's a geo map, or it's a heat map. And a heat map is using the wireless triangulated information to display that. So that's for another demo day. So what else? We've shown the email. From the email, you have hot links to get to the Jira ticket, and that's basically Jira ticket. Basically, has exactly the same information as we have seen before. And that's probably it. Did I forget something that we want to talk about? No. We have the responses, different responses. Just wrapping up. Different types of responses. You can combine it: service tickets, cross-domain, blacklisting, custom workflows. Extreme, non-extreme, doesn't really matter. For access layer enforcement, access control is really important. It's a key component. So access control gives you security, but also access layer automation. That can be tied into fabric technologies. That's part of the policy definition. Layered on top of an existing analytics product. Machine learning, talked about that.
Markus, the quarantine moves with the device. So if they
the quarantine is persistent. So if a client moves from one port to the other, or a client moves from one access point to the other, obviously the policy moves with that device. So when it's blacklisted, it's persistently blacklisted. So there's no way out, so to speak. Yeah? I think that's it from my side. Just one last word, the flow cache. When I said flow cache, that's basically what Ranjan mentioned before as well. So when I say flow cache, and what we will create as part of the forensic package is basically we will fetch everything in that cache here that is going from or to that device. So let's see whether the device is really here. So we can filter down, obviously, based on any criteria, and that would become part of the forensic package, which then can go into an email or can be stored elsewhere. Yeah? And that includes everything about the flow. Also, if we have, that's also interesting, if we have multiple, which we don't have here, interfaces, then we can also start to stitch together an active path for a given flow throughout the network. And when I say stitch together, we know as multiple devices report the same flow, we know what active path that flow has taken, which is interesting in an ECMP environment where you don't really determine properly what path you're going to take unless you fetch all of the FTP information. And even then, the problem is you can't predict what hashing algorithm a given device is using. We do it on the reverse side. We just look at the flow, and the flow will give us the information what port and interface a flow has taken throughout the network. Yeah? And as we support that across our entire portfolio, you get an end-to-end view. Yeah? And we are removing duplicates by homing networks to a certain appliance. Other appliances will throw that information away, and we just keep the path information, and that's it. Yeah.
Just to be clear, is this a shipping product or roadmap or?
Security analytics is roadmap, yeah. It's in development right now, yeah. Analytics, what you've seen before, that is a generally available product. Actually, I figured out that in 2013, I did an analytics demo as part of Network Field Day. It was probably Network Field Day 0 when we released the product in 2013. So that's a product that has been around for a while. The security part on top is what's unique. All of the workflow capabilities are also shipping capabilities. It's really the security and the machine learning anomaly part that is roadmap. Yeah.
When Markus said it's a roadmap item, I think it's actually a lot more than that. Earlier you were asking about false positives. So since this is fairly new technology and we're chartering new territory here, we said let's do an extended field validation. So otherwise, it would have been in a released product. We're doing almost like a 6-month field validation test. And the 0 false positives that Markus was mentioning is all in lab environments. They haven't been put into real-world environments. That's when
no, they're also in customer.
Some cases there.
Yeah, in customer lab environments, right?
No, in customer production environments. You're behind with.
You're allowing customers to put that in production. All right.
That's a sidebar.
Yeah. That's another conversation. Yes.
If the security piece isn't GA yet, if customers were to buy this thing like today and then decide when the security piece is ready, is this like a license? Is it a rip and replace?
I'm R&D. It's not. I can tell you it's not rip and replace, but we are still figuring out our go-to-market strategy for that. So, yeah. It's definitely not rip and replace. So going back to the machine learning part, it's super lightweight, so it can run on anything that we ship today. So those analytics engines are typically 64 gig of RAM, 24 cores. So it's beefy, so there's enough to do those kind of interesting things. Yeah. Oh yeah, just one thing on the, I think you mentioned that before, on encrypted traffic. So if you look at HTTPS here, depending on what you use, you still get enough data to make a call on what application might be behind that given encrypted session. So for example, here, Salesforce, we detected that based on the TLS server name. So we just read part of the certificate. Yeah. So there's enough. I mean, you could argue that for content security and data loss prevention, that is insufficient, but we do only application detection and anomaly detection, so we don't need to decrypt. So it's much simpler from a deployment perspective for us. And we don't want to get into content security. There are different companies who do a much better job than we in that space. Yeah.